Everybody doing well? Any questions on any of the quizzes or homework problems? Now, everybody notices, because I have to repeat things 10 times, that after you take a quiz that evening, probably by 6:30 or so, I will post it on CMOS EDU. So last Wednesday's quiz is right here. And the homework is, thank you. And the homework is right here. All right. Any questions on any of the homework or quizzes or anything like that? It's all going well and it's all making sense. Let me tell you a little secret. When the midterm comes, I'm going to go look at the homework problems. I'm going to look at the quiz questions. And I'm going to copy them. I'm going to copy homework and quiz questions and change a number or two, and that'll be your midterm. So if you go through and you can't do some of the problems, guess what? You not only get a bad grade on the quiz or homework, you also get a bad grade on the midterm. But then you know what I get? I got to make sure that you know what's going on so that you will go out and you feel confident and you understand what's happening. Not, I don't know. All right, any questions? Yes? On the homework? Yep. You're paying for this, get your money's worth. I know, what a novel concept, huh? Number 4 is this one. All right, so I'm going to do this for you 2 ways, and I want you, now again, when I do it, it looks easy. So when you practice for the final, or the midterm or the final, you need to make sure that you can do this without looking at how I do it, all right? So what I'm going to do right now is I'm going to copy this circuit over. And then I want you to take a picture of this with your mind's eye. And that's a VS, VX. I'll switch over as soon as I get through copying the circuit. And then let's have a current like this. And 1 milliamp. And it says, find the voltage across R1 as indicated in the following circuit. So, oh, I thought I already, why did it, I already started this. I don't know why it decided to close it on me. Is anybody still using the videos? Do you use the older semester videos? All right. A little bit, because I'm getting better with age. All right, so tell me, it's asked to find, did I copy it right first? Okay, so it asked me to find what? Voltage across the 1K, which is what? VS minus VX. So when you look at this problem, I can think of several ways of doing it. I'm going to do it the way I would imagine you would do it, which will be the little bit, I don't know if it's hard or easier, I can't tell at this point. But when you look at this, the thing that you don't want to get confused with is trying to find VS and VX at the same time. So if I find VX first, how do I find VS? Yes? I mean, you can do all kinds of stuff, but what's the simple way of finding VS if you know VX? Voltage divider. You're going to use that over and over again. Okay, so here's the trick. I don't want to find VS and VX at the same time. I'm only going to find VX for both ways I work it. Would this be a good quiz question? Maybe not today, but maybe on Wednesday. I don't even remember. I did the quizzes a few days ago. And I already made Wednesdays and today's up. All right, so here's what I'm going to do. I'm going to notice that this plus this is what? 1.5K, and I'm going to redraw the circuit. And I want you to make sure you follow what I'm doing. So this 1.5K here is this 1.5K I'm drawing right here. And then I have a current. coming down there of 1 milliamp. And now I want to ask you, does anybody agree with that? Okay, but what did I lose when I went to that schematic? VS. Does that frighten me? Nope, because I can go back to the original schematic and find VS. Now, what do I label this wire, this node right here? VX. Anybody not follow that? I haven't messed with anything over here, so this is still VX. All I've done is combine the resistors and I put them going to ground like this in a straight line. Okay, so now, I know what I would do if I was solving it at this point. Tell me what you would do. I could combine the two resistors into what? One resistor of 750. Because remember, I told you, when you see like resistors and you put them in parallel, all you do is you have the value. You don't think about it. I'm not going to do that. I'm going to make it a little harder. Okay? Because if I combine those 750 and then I got the 1 milliamp, I get VX as minus 750 milliamps because the current is flowing backwards. So wait, let's see. If here's my straw that I've drawn as a resistor, it restricts airflow, right? If I'm taking a drink out of my soda, am I applying positive pressure or negative pressure to get that out? Is the pressure I pull, is it pulling or is it pushing? Pulling. So I expect that to be a negative voltage. It's a negative pressure. I don't go out to fill the car, my car tires, and pull air out of them to fill them, right? If I'm going to put air in them, that's a positive pressure. I'm going to pump them up till the tires get filled, and that's a positive pressure. If I pull the air out, if I take a drink of my soda, that's a negative pressure. I'm pulling something out. I'm creating a vacuum. Does everybody follow that? I'm trying different ways to make it sink into your heads. Is it clear? Yes.
Well, the way you've drawn it, it's going from plus to minus, so
yeah, so you write, it's a negative pressure, so I write minus V equals I times R, or the way we've been doing it, V equals minus I times R. So if I pull 1 milliamp backwards, everybody agrees that here and here I'm pulling it backwards, right? Going in, that this Vx is going to be a negative value. Everybody sees that, right? And you understand it doesn't bother you. When you see a current being pulled backwards, you think, I'm taking a drink of my soda, applying a negative pressure. And I won't give you the analogy of going the other way in your soda, right? All right, so any questions on that? And I will, just real quickly, and I'll do this, I'll write 750, but this isn't the way I wanted to do it at this point, so I'm gonna redraw it. 1 milliamp, and then this voltage is 750 times 0.001. And let me put that in parentheses. And what's 0.001? 1 milliamp. And it's negative. And what's the value? Minus 750 millivolts, or minus 0.75, or minus 3/4 volts. I don't know what you like, so I'm giving you all of them. Does that make sense? I'm pausing on this for a reason. When I was learning the current going backwards through the resistor, it didn't go, oh, I got that. And I'm going through different ways so that you get it, you have a different looks at it, and it doesn't challenge you, because we'll be doing this the rest of this semester and next semester. Whether it's AC or pulses or whatever. All right. Let me redraw this circuit again. And let's redraw it like this. 1.5K, 1.5K, and down like this, 1 milliamp, and this is Vx, and I'm going to show you another way of doing it. Everybody agree this circuit is this before we combine the resistors, right? So now I'm going to do a KCL. And what was that? Kirchhoff's current law. It says the current that goes in has to equal the current that goes out. Just like a plumber knows the water that goes in has to equal the water that goes out. So I'm going to write now on here the current through here, which is what? No, think simple. What is the current through here? Vx. I don't know Vx, I'm still solving it. So what is it? No. Simple. No, I forget this. Forget I solved it already. We're back here. Don't give me numbers. I'm back here. Simple. The way you learn stuff, the way you go up the stairs is step by step. Here, what is that current? Right on. Anybody not see that? And I could put the plus minus and label it as Vx. Yay? What's this current? Same thing. What's this current? And don't, if I add all those currents, don't they have to sum to zero? Everybody see that? I'm doing a KCL. Any questions? Yes? Well, you're killing me, man. I'm lazy. You're pointing out I'm lazy. So, I've been lazy. What did I not draw? The wire. When you draw symbols like this, I'm not drawing the wire across. Don't point me out and tell me I'm lazy, man. They all come back, right? And these two currents go around and around, and they'll sum to zero. So if I go over here, I get Vx equals minus 1 milliamp. I factor the Vx out times 1 over 1.5k plus 1 over 1.5k. Or minus 1 milliamp times 1.5k in parallel with 1.5k. Or minus 1 milliamp times 750. Or minus 750 millivolts. Does everybody see that 1 over the two resistors is, just because we're learning. Let me move this bead down here and move this one up. And I get Req equals 1 over R1 plus 1 over R2. We all agree with that? Does it make sense? Yay or nay? Okay, so now, no questions. If I give this on Wednesday's quiz, you guys are going to be like, he's not challenging me with such easy problems. I'm not done. I'm going to go through and solve for the voltage across the resistor, if that's what you're asking.
No, I was going to ask you, can you do it using 3 dividers?
No. The reason, you could find what the current is in both, but they're the same value, so it would be a half milliamp through each. That would work, right? But in the original circuit, well, I guess you could in the original circuit too, yes. You just do a current divider. Yeah. All right. So why don't we go back here? Everybody follows this. I'm not getting anything from you. I'm not getting, or, all right, getting a thumbs up. All right. You're late, man. You know what I like to do? Someone comes in late, I like to turn the camera, the dot cam over on the audience. Oh, I have a good sense of humor. No, you don't. All right, so tell me, what do I label this voltage right here? Try to be different. Everybody agree with that? So, what is that voltage right there? Well, I got a 1K, and then this is twice as much. So what can I say about this voltage drop compared to this one? Twice as much. So I'm going to drop 500 millivolts across here and 250 across there. But I'm a student, and I don't like him doing that practical crap. So I'm going to go back and say, oh, well, I'm going to write here. Let's write it. Let's draw the arrow up here and write VS equals minus 3/4 volt times 500 all over 500 plus 1K. And what did I just apply? Voltage divider. So VS equals minus 1/2 volt. I'm not done. Go ahead.
So you can use the voltage divider even though you don't have a voltage source?
Yeah.
Okay.
You can use a voltage divider as long as you don't have a voltage source, as long as the 2 resistors or 3 or whatever have the same current flowing through them. So those two, the water flows or the current flows, right? So I got this voltage here. That's why we use it over and over again. I mean, in the current divider too. So that's why I used it right there. Now I could go through and, oh, this current here is minus 3/4 divided by 1.5K. Then this voltage is that current times 500, but it's the exact same thing. Question?
I think the number is wrong. That's not, it should be.
Oh, yeah, 1/4, sorry. It should be 1/3 times 3/4, which is 1/4. Right? Correct me, man. Keep me honest. Okay, so let's see. I got minus 3/4 there, and I got minus 1/4 there. Let me pause and ask any questions. Yes?
Well, I did it by doing the VX.
There's lots of ways to do it. This problem is good because there's so many ways to solve it. But I don't want you to go to a job interview and tell someone put up a circuit like that and you're a graduating senior and you go, oh, well, circuits was a long time ago. Oh, thank you very much. See you later. Okay, so the question asks, what's the voltage drop across the 1K? Let's write the answer. What is it? Minus 1/4 minus 3/4 or 1/2 volt. Anybody get that? Did that answer your question? All right, I don't want you to tell people you're getting ripped off. If someone else had a question. Nobody else had a question? All right, yes?
Wouldn't it be negative 1/2 because it's VS minus VX? So, or no, never mind. Figure it out.
Tell me I'm wrong, man. I love that. I love being wrong sometimes. All right, no other questions on any of the quizzes or homework? Yes? Yes, I can. Would you be disappointed if I said, no, I can't? That's too hard. I like to challenge the students and give them problems I can't do. Quiz, you said? All right. All right, it says find the current flowing in each circuit. Oh boy. I mean, yeah, in each circuit. I shouldn't even have written this one down. So that's the current flowing. Why do I say that?
0.
Yeah, it's 0, but why? Explain to me why it's 0. Yeah, so if I take this side and I ask, what's this voltage? 1.5. If I take this side and I say, what's the voltage? 1.5. If I ask, what's the voltage drop across the resistor? It's 1.5 minus 1.5 or 0. So let's say that I have a tire pump. And the maximum it can pump up to is 30 PSI. And I go out to my car and I start pumping, and my tires get to 30 PSI, and my pump can only go to 30 PSI, and I keep working. How much air is going into those tires? None. That doesn't bother you. There's situations where the pressure on each side is the same and you don't get any current flow. Any questions on that one? I did that one on purpose because I don't want everything to be always like cut and dry, calculate something. No one's going to miss this one. All right, let me do just one for you that I might put on a quiz, and let's see if you get it. Let's just throw something different.
Isn't there a current outside?
There's a current flowing here.
Yeah.
Yeah. But that's not what the problem asks you. It asks you, what's this current? It's like saying to me, what's 5 plus 7? And I go, 1 plus 1 equals 2. It's not the question. Yes. Let me do this one, then I'll do number 2 from homework 2. Then we need to move on to superposition. Homework 3, the one that we turned in today? All right. Do I need to draw a wire from here to here?
No.
Thank you. Okay, so I want you to find the current and voltages that flow, the current that flows in the circuits and the voltages in the circuit. Okay, pay attention to this problem. I want you to find the voltages in the circuit and the currents. Let me tell you what the voltages aren't. This isn't 1.5 volts. There's not a voltage source going to ground. This isn't 1.5 volts. There's not a voltage source going to ground. The voltage between here and here is 1.5. Everybody got that? So you're on the quiz today. You look at this and you say, okay, how do I solve this problem? My quiz grade's crashing and burning. Tell me what to do. Okay, but tell me something simple to do first. I mean, I'm learning. I can't go to the answer. I need something simple. Grounds are 0. We know that. We'll not write that at this point. Yeah, I don't know how to combine the resistors.
Can you just do a voltage divider?
Yes, you can. We're going to do it that way in a second.
Solve for I, then do VAR.
All right, so here's how I would do it, and I'm going to do it. Solve for I is correct, but indirectly. Here's how I'm going to do it to teach you, and then we'll do it a different way. Okay, because I don't know what might be asked. This is the question, this is what I was looking for. This voltage is V1. This voltage is V2. V1 minus V2 equals 1.5. Not, so far not challenging, right? This current is what?
V1 over 1.
V1 over 1K. This current is what? V2 over 2K. All right, what can I say about these two currents? They got to be equal. There's only one current flowing in the circuit. Everybody agree with that? But I've drawn them in opposite directions. Okay, so let me pause and I'm going to plant something in your heads because students love this. I don't know why. This node here where you have a voltage source between the two, they love this. When I was teaching this the first few semesters, are you going to cover supernodes? This is called a supernode because one side is the same as the other just by a voltage difference. Okay, I don't like that crappy terminology, but textbooks and other people love it. It's a supernode. Okay, so I'm going to do a KCL out of that supernode. All right, okay. I guess it's I don't know what it is. But would everybody agree V1 over 1K plus V2 over 2K equals 0? Would you agree V1 minus V2 equals 1.5 volts? Would you agree I have two equations and two unknowns, and so I can solve for both V1 and V2? Boom, done. And I got V1, I got V2, I got the current through the 1K, I got the current through the 2K. I know what the current through the 1.5K is, whichever way I define it. If I define it this way, if I define it like that, it's this current. If I define it like that, it's this current. Do I need to solve the algebra there? I do? All right. I'm going to put that in there of 1.5 plus V2 over 1K plus V2 over 2K equals 0. Anybody agree with that? Now what? No, make it easy, man. I'm going to multiply both sides by 2K. And then I get 3 plus 2V2 plus V2 equals 0. Anybody agree with that? Then I get, I'm feeling the pain here because I can just look in this and see what the answer is. Anybody not follow? And so what is V1 then? Okay, this would be a problem I'd give you on a quiz. I don't want anybody to not follow. So if you don't follow, tell me. Yay or nay? The way I did my math is crazy. It's 70s math. What's that? Now what? Find the currents? Wait, I'm not getting a good feedback. Let's ask Beto. You happy or sad? It'd be funnier if you said as happy as I could be sitting in a circuits class when there's nice weather outside. Any questions? So let's find the currents. What's this current? How do I get that? 0.5 over 1K. So without thinking deep, what's this current? Minus 1/2 milliamp. Tell me why. I'm saying not thinking deep. Tell me why. Water flows that way. They have to be equal. If I draw that one the opposite direction, it's got to be the same value but negative. Yay or nay? You're blowing my mind, man.
Yeah, so the current is the same as
The current is the same as what?
in the whole circuit.
Has to be. Think of plumbing and pipes. Where else is the water going to flow? Now, if I put a T on there in the right side, then I could pull some current out. Then the 2K current may not be the same as the 1K. Proceed or stop and shed a few tears? Proceed? All right. Any questions on this problem? Quiz today. Wait, what? I need to pay attention now. All right. You'll find I don't lie to you. So, unfortunately. All right, what was the problem? Who asked me? Number 2. On today's homework, how was today's homework anyway? Too easy?
I don't know about that.
Just right. Number 2, this one? All right, let me ask this. What is Vx? Well, wait a sec. You know, I've had this in my other class, but everybody knows I'm recording videos and then thinks we go over in class. Like I have someone from my other class come in and goes, can you go over how to do problem 2.16? And I'm like, I did that in the last lecture. What the hell? Oh, you did? Everybody knows I'm recording the videos, right? You can watch things I've gone over. You didn't know that? All right. Okay, so let's do this. Let's pause on this part of the circuit because I thought this would be easy. Apparently it's not. Let me sketch it. Is it going to bother anybody if I don't draw this part of the circuit when I analyze this part? Why not? Really? Is that right? Are you sure? I have to find who's talking, yes. Yeah, the source decouples, right? Now, does that mean the same current? No, that pump, that 1.5 volts will supply current to the left and it'll supply it to the right. So at this point, I'm thinking, damn, I've done a damn good job and no one's going to be challenged by this circuit. So this is where I try to rile you. No, you haven't. I don't understand. Okay? So what is this circuit called? Voltage divider. And what's that voltage? I don't like thinking like this. What I like to do is I like to go 1K 500. This is going to drop twice the voltage of this. So if this is 1.5, I'll get 1 across there and half across there. Then I'll need to do math. Well, but it's not algebra like this, right? I'm just thinking. Okay, any questions on that part of the circuit? Yes? No. That's why I'm going through the pain. Well, at least it's painful for me. I don't know, probably later in the semester or the midterm, if you just say, here's the voltage divider and this is, and it's like this, I'm gonna go, come on, you know. I won't take points off. But you know the grader, oh, does everybody know who the grader is? Do you know how to get a hold of the grader? You know what I should have done? I should have put his name on the course webpage and his office hours and his office location. It's like when I have a quiz, I should put the quiz number on the top of the quiz before I have, oh wait, I do that. Okay, I can't tell you how many times. What quiz is this? I have to look at it too. All right, let's do the other part, which I assume is the challenging part. So this is 500. What are these three in parallel? 500. So would everybody be okay if I drew the right side as 500, 500, and 500? S, Y, Z. So I go over here and I've got yeah. So what's the voltage drop from here? 3 500 ohm resistors. I don't know, man, you're blowing my mind. VZ equals 1.5 times 500 over 500 plus 500 plus 500, which is, so what's this voltage? What's this voltage across that 500? What's this voltage across that 500? So what is Vy relative to ground? V is equals 1/2. Is that a challenging problem? Yes?
So when I did the simulation,
Yeah.
so why do you have to do it that, like draw it that specific way for the?
You mean like this?
The parallel divider?
No, I don't. I want to analyze it. So I get 500 ohms. So now if I go back to here and it says, what's the current? The current through here is going to be what?
I was talking about from R4 to R6. Why do you have to draw the R6?
You don't. You can put them like there's three 1.5 Ks in parallel.
Because when I did a simulation, it resulted in different numbers.
You want to bet?
Yeah.
I'm from Las Vegas, man. You want to bet? No, I'm not going to take the time to simulate that. Come to my office hours. All right, any other questions? Let's do superposition then, which will be the next thing. I mean, it's all there. You just have to bend down and pick up the gold and learn it. Make sure you get it into your brain so that when you go for your job interviews, if it's a job where they require circuits knowledge, you can do these things, all right? And believe me, we're doing enough that you're not going to have any problems. I told you why I started teaching circuits, right? I didn't tell you why. So I taught, you can look at my courses, for years and years I taught senior, once in a while junior, senior grad, because I'm very research oriented. And I started sending students out to industry, and they got into certain companies that are very, very picky about who they hire. They invited me up and we want to hire more of your students. So I was like, okay. And so I gave them some names and sent them up there. They hired 3 of them. It's a very, very selective company. And the student got talked to on the phone, and they asked him some simple voltage divider equations, and he's like, I can't answer those. I can't. It's just simple circuit stuff. And you know what that did? It shut the door immediately on hiring more students. And you know, maybe you want a piece of paper and that'll make you feel great. And I got a piece of paper that says I have a degree, I mean, that doesn't mean anything, at least to me, unless you can make money and get a good job and have a job that's fulfilling, not just something that's repetitive over and over. All right? And so that's why I came back and I'm like, crap, I got to teach circuits so that people can pass these interviews. So here I am. I actually like teaching circuits. What's that? No, I mean, everything once you know it is easy. Like I can teach the hardest grad classes and it's the same as teaching circuits because I know it backwards and forwards and I've been doing it for years. Circuits is harder because it's a different way. You have to get people used to thinking a certain way, right? You know, it's like algebra. You have to think a certain way when you look at something. You know, a lot of times I found when students come into my class, they're used to math, and they're not actually used to doing something realistic, right? So I want to make sure that they can do the math, that's important, but also look at a circuit and know what's going on. So let's go talk about superposition. And this is super useful. Not so much like a supernode, but superposition is super useful. So I want to do the problem we just did. Oh, before I do that, on this problem here that we talked about a moment ago, you can do this problem using a voltage divider, right? It becomes a little bit more challenging because of the plus and the minus when you do the voltage divider, because it has to be relative to the minus and the plus here. So you would do the voltage divider, and if you did that, and the reason I didn't do it is you would end up just saying 1 volt and 0.5 volts, because you would need to know that in the voltage divider, when you do this, all of the pluses and the minuses have to be oriented, or I guess I should flip it around like this, so that they sum up to the 1.5. So that's why I did it this way. Okay, you can do it whatever way you like. If you did it in the end and you did this voltage minus this and it didn't come out to 1.5, then you would know you had a sign error. Okay? Did that confuse anybody? I'll go over it in a sec. Let's move on. So superposition, if I do that same problem, or I do a similar problem, let's do this, because we've already looked at this problem. and I put 1.5 volts there and 1.5 volts there, and I tell you to find the current through that resistor. And you say, gee, that's 0. You say this is 1.5, this is 1.5, and then this current would be 1.5 minus 1.5 all over 1K or 0. And that's the way you've learned it, right? But if I tell you to solve for the current using superposition and you did it that way, you would get 0 credit. Superposition is you look at one source, one voltage source or one current source, one source at a time. For the voltage sources, you replace them with a wire. For the current sources, you open them up. So I said that. What does open them up mean? Open mean? Pull them out of the circuit. I take that component and I pull it out of the circuit. I don't put a wire in, I don't do anything. I just remove it from the circuit, done. For the voltage source, I pull out the voltage and then I replace it with the wire. So I'm going to do this problem using superposition, and I know what the answer is, but I want to just illustrate it. Superposition is super useful. You can take a really complicated circuit and figure out what's going on just by looking at one source at a time, because then it allows you to combine stuff. Okay? So let's look at this source first. So I have this source first, and I've got 1.5 volts, the 1K resistor, and then I replace this with a wire. So I have this. And this is 1K. And now here's where I will cry if you can't tell me what the current is in the circuit. See little droplets of tears hitting the paper. Okay, so this is 1.5 volts. This is ground. So this current is 1.5 minus 0 over 1K or 1.5 milliamps. Anybody not follow that? Then I'm going to use this source. And when I do this source, what I'm going to do, and you know what, I'm going to be, so does everybody see, when I look at this source alone, I've shorted this one out. So I've got a wire there, but I put this one back in. So instead of drawing the current like this, well, we could do it 1.5 milliamps because it's the same exact circuit. I'm going to be a little bit tricky. And I'm going to do this and say, what's this current? It's 0 minus 1.5 volts over 1K or minus 1.5 milliamps. So then when I put the circuit, does everybody follow what I've done? When I put the circuit back together and I ask, what's this voltage? This voltage here, it'd be 1.5 plus 0. What's this voltage here? 0 plus 1.5. What's this current? It's going to be in this direction, 1.5 milliamps, and in the same direction as this where I've got drawn here, plus minus 1.5 or 0. Does everybody see how that works? So I've used superposition to find out everything in this circuit. Okay, so I want to make a little bit more challenging problem, but before I do, I want to go back and do that voltage divider thing I promised I would. Then we'll do a different, more challenging circuit. Any questions about this? Yes?
So you see how if you had drawn the current going backwards, then you would have not added, but you would have subtracted.
Yeah, because this current, the one they asked me to find, is in this direction. So it'd be this plus a current in here going, and so I'd have to flip this around so that it's minus 1.5. So I'd have to add them in the same direction. Questions? Okay, let's go back and do that quiz question again using a voltage divider. But in order to do that, let's review the basic voltage divider equation again. And we'll just write this as V out. I must favor red because it always dies first. V out, and then if I ask what are the voltage drops in the circuit, plus, minus, and then minus plus. You see how if I start running, here, let's draw this around. Here I am, and I start running. I go up like that, and I go minus plus, and then the other two are plus minus plus minus. Everybody see that? So if I have the following, and I'm going to use, and so V out is equal to R2 over R1 plus R2 times V in. Everybody's got that, right? If I go here and I call this plus minus V in, R1, R2, and let's go ahead here, and let's measure the voltages. And I start running, let me start running here. And I go up and I go minus plus. Then this will be plus minus. Then here I am, and I'm going to continue running around. What does this have to be? Plus minus. So if I use this now, I write this voltage, let's call it V whatever, is equal to V in times R2 over R1 plus R2. V in was 1.5, 2K and 1K. So again, I get V here is equal to 1 volt. Using the numbers from the previous example. However, if they ask you what's the voltage in this direction, what's the answer? Flip it. Minus 1. But you don't have to do it this way. You don't have to use the voltage divider. You can do it the other way we learned. Unless it tells you, use a voltage divider. Any questions? Let's go back to superposition. I want you to do well on today's quiz. Because what's the goal? Everybody to get A's. Speaking of which, let's see how that's going. Homer Simpson, dope! All right. Well, it's like 1% of the grade is done, right? So you still have 99, so those grades don't really mean anything. If you're getting an A, doesn't mean you're not getting an F. Thank you for the support. Let's do this problem right here using superposition. Why am I using 1.5 volts? What's that? No? No, it's what common batteries are nowadays. AA, AAA, the CR25s or whatever. All right. So I'm going to use superposition. So I'm going to do this in 2 steps. So what do I do when I'm using superposition when I'm only doing the voltage source? Current's an open. Oh, I like that. Now, you may not like it, but you should. Whoops. So what's this current? 0. Anybody not agree with that? There's no place for current to flow. 0, right? What's this voltage? Okay, now here's an interview question. What's this voltage? Oops, I wrote it on there. 1.5. Explain to me why, in simple terms. There's no current flowing in that resistor. There's got to be no voltage drop across it. Therefore, both sides have to be at the same value. Burn that into your head. No current through a resistor, both sides at the same value. Everybody got that? It's 1,000,000 volts here. There's no current through the resistor. What's there over here? 1,000,000. Yes?
So there can be a voltage with no current.
Yeah. There's one right there at the wall. 120 volts RMS. You'll find out what that means by the end of the semester. Battery. There's a voltage across it, no current's flowing. Can I push without something moving? Sure. Can I have tire pressure? No air coming out? Sure. Okay, so I got 1.500. Now I'm going to go over here and I'm going to do short out. Does anybody think I go too fast? Yes.
You go too efficiently.
I'm efficient. 1K, 1K. Does everybody agree with this? What's this voltage? 0. It's connected to ground. I replaced the voltage source with the short. What's this current? -1 milliamp. Anybody agree with that? You guys are going to start walking around like this at UNLV, like you're circuit gurus, right? Then you're going to have your robes and you're going to be like, yeah, circuit guru. All right. Now, last question. What is this voltage here, plus to minus? How much current flows? Well, wait, you just labeled that -1. Well, wait, I'm saying plus to minus. -1 would be for the arrow like this, right? So if I say this, don't let clutter get in your mind. You got a current going through a resistor. Don't think deep. 1 milliamps being pushed through that resistor. This is 1 volt. Who agrees? Don't get confused. But you minus, plus, blah, blah, blah. It's a resistor and a current source. Bottom line. Step back. Okay, we ready? Let's see what the values are in the circuit. What is this voltage right here? 1.5 plus 0. What is this voltage right here? 1.5 plus 1, or 2.5. Any questions about that? This current, what is this current? 0. What is this current? -1. So what's this current? Does it make sense that this current's -1 milliamp? Or what if I draw and ask you, what's this current? Well, if I have 1 milliamp flowing through a 1K, what's the voltage drop across it? 1. 2.5 minus 1.5. Yay? Is it making sense? It will after I watch the video 3 times on half speed. Don't worry, by the time you're seniors, you'll be watching my videos at double speed and laughing because I sound like a chipmunk. Question?
So on the left, current is 0.
Yeah, where's it going to flow? Did you go use the bathroom or something while I was doing that? Go before class, man. All right. Any questions on this before I do a 2-looper? 2-looper, good? All right. How about this circuit right here? Crazy. Oh, by the way, how would I get 3 volts with 1.5 volt batteries? Is this okay? Better be. I bet a lot of the stuff that you do has 2 batteries in series or 3, like your consumer electronic stuff. Yeah. Of course, nowadays, everybody uses their cell phones. Okay. Tell me what to do. This is one where superposition's good, because I don't know how to approach it just looking at it. It's confusing me. And I want to do it nice and easy. So I'm going to take and get rid of this one first and just use this one. Does that sound good? And if I do that, what's that? Let's call this V1. What should I call this? Tell me something that makes my life easier. No, not V2. Supernode. Da-da-da-da-da. V1. Here I am at V1. V1. What's this voltage? What? V1 plus 1.5. Stop making things hard. I'm going uphill. Got to get in shape. I'm going to run up that hill. Right? 1.5. So now I'm going to go and I'm going to write this is V1. I'm not going to worry about this for now. Just write V1, 2K. Come over here. 3 volts. And I'm going to write this voltage is what? 3 volts. Does this seem like a more reasonable circuit? Does it seem reasonable? No one's like, no, doesn't seem reasonable. Does everybody see what I did? Okay, now what? Who keeps talking over there? What do I do now? Combine the resistors into and 2K and 3 volts, and then I get, what is this voltage label-wise, not value? V1. Everybody cool with that? V1 equals? Okay, again, I'm looking at this going, I got 4 times the voltage across this one, but let's go through. You love math, so. Everybody agree with that? Do you agree with it when you can see it? Get rid of those 2 zeros. That's 5 over 25, or times 3 times 3, or 3 over 5. And so this voltage is 0.6. This current is what is this voltage again? 3. What is this current? 3 minus 0.6 over 2K. Pause. I'm going too fast. Tell me when. The pain. Don't worry, I was there once too. Which is, ask me, man. If you have a question, ask me. No, it's okay. Let me ask somebody in the studio audience. How about, don't make eye contact, don't make eye contact. I don't know enough people's names. Abraham, I know your name. Does it make sense? Do you speak for everybody in the classroom? All right. This question, 3, 2.6. Does everybody see how I got points? Well, I said 0.6. I'm assuming everybody knows how I got 0.6. Where did I get 0.6 from? 3/5. Sorry, my brain's like, I don't know, it's the same, right? Okay, and what is that current? 2. I know what it is. And we're 2K, which is 1.2 mil. Students don't like it when I just write the answer. How'd you get that? 1.2 milliamps. We're running out of time, but let's do the other one. Let's do this source. All right, now I'm going to sketch the circuit here kind of sloppily, and then I'm going to go sketch it on the next page, and then we'll do our quiz. 1K plus minus 1.5, 1K, 2K, ground. What's 2K in parallel with 1K? Let's see. 2K times 1K over 2K plus 1K, which is 3KK over 3K. The K's cancel. 2K over 3K, or 666 ohms, the devil's resistance. All right. So I'll replace this with the 666 ohms. What'd you learn today? I learned the devil's resistance was 666 ohms. All right. Oh man, that looks familiar. Today's quiz. Tell me what you're going to do. Let's do it real quick. Let's call this V1, then I'm going to call this what? This current is? This current is? This is your quiz. V1 over? This node's called a what? Supernode. And so this current plus this current equals 0. And can you solve this for V1? My algebra went like this after circuits 1, especially the bead thing. All right, any last second questions? Yes?
Could you do that by finding the second first?
1.5 over 1.666K? Yeah. All right.